This is lesson 10.5, translating sine, cosine, and tangent functions. The objectives of our lesson today are to graph translations of trigonometric functions and to write equations of functions. All right, so I want to start with a warm-up to remind ourselves about translations. We've done transformations, shifts, dilations, reflections in the past, like we did ones on square root functions, we did ones on cube functions, right? And so it always turns out that this number out front happens to be the reflection and the stretch. This is your right and left shift, and this is your up and down shift, right? So it's kind of cool. All functions are like that. So this one has a reflect over the x-axis, a stretch by 2. Now remember, this is in with the x, right? It goes, the h, it always goes opposite. So this is a -3, meaning it goes right 3. And then the y shift goes up 4, right? So this one is going to be a stretch by a half or a shrink, right? And then we're going to go left 1. Remember that whatever number is with the x, it goes opposite of what it should. And then down 3. Okay, so now we're going to take the same concept and we're going to apply it to the sine, cosine, and tangent functions. We've been graphing them already, but now we want to kind of reword it in terms of shifts. And so we're going to look at slightly more complicated sine, cosine, and tangent functions and be able to graph them using our knowledge of shifts. Okay, so I want to start out here with a demonstration. So I want to look here. So here you can see now I have a much more complicated graph, a sine bx plus h plus k. We already know what the a and b do, right? A affects amplitude. We already know that. A is the amplitude, right? And the reflect over the x-axis, it can do that too. So amplitude and reflect. And in a way, that's the same thing as a stretch, isn't it? The amplitude stretches the graph. And then b affects the number of cycles that occur between 0 and 2 pi. So b is the number of cycles. Let me just set this back here to 1 really quick. All right, so let's explore h and k. So as I move this, you can see h moves left and right, just like in all of our other functions that we've done. So it's the same as everything we've done before, right? And in fact, you can see h also moves backwards just like before, right? It's moving backwards. Now what about k? Just like before in every other function, k moves it up and down. Notice that the shape doesn't change at all for h and k, just the placement of where the function is the only thing that moves, right? So that's the only thing that moves on h and k. So if I move this here to h is 2, k is 3, then the center of my sine, instead of being at 0, 0, is now at -2, 3. All right? All right, so let's start with the first problem on your in-class assignment. So true or false, the A is for both the amplitude and the stretch of the function. So we think about this. That is true. The amplitude is a stretch, right? When you make the amplitude higher, you're stretching out that sine function, right? Or the cosine function. It's true, and especially true on the tangent function, which doesn't have amplitude. It only has stretch. So this is true. A stands for both amplitude and stretch, and so when you're working with sine and cosine and you state your translations, you can actually say it either way. You can call it an amplitude or a stretch. How about this one? True or false, when you shift left or right, you always go opposite the sign for the h. So that one is true. Remember, h goes opposite. So why does this happen? So think about any function, right? This is just a function in general. Y equals any function in general written in this form. This is kind of like the transformation form, right, that we've come to know. If you plug in 0, right, if you kind of ignore the x values for a second, what do you see? Y equals k. You see y equals k. So k is equal to y. It moves up and down the way it should, right? It moves up and down in a way that makes sense. But what about this? The h is in here with the x. If you wanted to put this in x equals form, you'd have to add the h, right? So that means it goes the opposite. You need the opposite sign. That's why we write minus h in our equations. We write minus h plus k. The minus is there to remind you that h goes opposite of the way it should. All right, now why do we need the parentheses, right? Why do you need parentheses in here? Why do you need that? It's so that you know that all of this is inside the sign, right? In our other equation forms, when we were doing like x minus h cubed plus k, it's parentheses because it's all being cubed, right? We need parentheses in these to say that everything within this is being signed or being cubed. All right, so let's now try this. Here's the parent function, y equals cosine theta. Amplitude is 4, shift left 3, so we want to write the equation of this. So amplitude, that always goes on the outside, and then a left 3. So left and right shifts are our h, and they go inside with the x or the theta. And remember, it goes opposite. So if we want to go left, we need a plus 3. Okay, so there's our equation. Next one, parent function y equals sine. So we're going to stretch by 3, reflect over the x-axis. It's giving us the number of cycles and then shift down 4. All right, so reflect over the x-axis, shift by 3. Now number of cycles is the b from earlier. So that means that 2 pi fifths goes in front of the theta. They're not giving us a left or right shift, so we can close our parentheses, and they want a down 4. Okay, so that makes sense. Reflect, stretch by 3. Number of cycles is 2 pi fifths, which goes in front of the theta. There's no left or right shift, down 4. All right, let's do one with tangent. Reflect over the x-axis, right 3, up 2. So reflect over the x-axis, right 3. So if we want to go right 3, that's going to be a minus 3. And then up 2. Okay? All right, so now let's go the opposite way. Here's the function, and we need to describe the transformations. So I see a negative out front. That's going to mean reflect. Right? And then we have a 12 here. That's going to be the stretch. Oh, I can't spell. Sorry, guys. Let's erase that. Stretch 12. Okay. Next, there's no number in front of that, so we're just going to look at this one here. So that's a minus, which means right. So right 2 pi sevenths. Okay, good deal. So let's look at the next one. Y equals 4 cosine 3 pi theta. minus 5. All right, we've got a 4 out front, so that means it's stretch 4, or you could also say amplitude is 4, right? And then the 3 pi is in front of the theta, so that means that we have 3 pi cycles. And then finally, the minus 5 outside the parentheses means down 5. Okay? All right, now let's put together what we know and try to graph, okay? So 2 tangent theta plus pi halves minus 3. So here's what I do. Think of this, your h and k, as sort of your center. So negative pi halves, negative 3 is our center. So in other words, we can go to like negative pi halves, negative 3, and that's the center of the tangent. Instead of 0, 0, it's not going through 0, 0 anymore. It's going through here, right? So if it helps, you can actually make a dotted line right here, kind of like the midline, right? Okay, so next we have a stretch of 2, so I'm going to go like up 2 and down 2. It doesn't have an amplitude, but this shows how much it's being stretched by. This is how I'm showing the stretch, by writing that. All right, now in front of this is nothing, right? It's 1. It's really invisible, 1. So pi over 1 or pi. So you have to actually go pi from here, okay? We're going pi from the center, not pi from 0, but pi from the center. So if we want to do negative pi halves plus pi to see, right? So negative pi halves plus pi makes positive pi halves. So that's where we're going. And now we can put our asymptote in the middle and draw this. Okay? So hopefully that made sense. You can always pause and go back if you need to rewatch part of the video, right? This is a little more complicated. Okay, so let's try this one. We have a sine graph. So again, I'm going to look at my h and k as the center starting coordinate. So I'm starting this one at pi 2. So if I go here and do pi 2. So that's the center instead of the origin, right? So that's going to be where my sine graph starts and then curves up. So again, you can put a dotted line here like the midline. Okay, now negative, so it's going down first, and the amplitude is 1. That's invisible negative 1, right? So we go up 1 and down 1, right? So the whole curve is going to be confined within there. All right, now what about this? This is also invisible 1 here. Remember, sine has a period of 2 pi, so this is 2 pi over 1. So again, we're going 2 pi in either direction from pi. So if we go 2 pi, we've gone 3 pi. If we go 2 pi this way, we'll be at negative pi. Does that make sense? All right. So that means we're back at 0. So we're up, and then go to the middle. Like imagine crossing it in the middle. So it'll cross in the middle. So it'll be up and down, and there's one cycle. Okay? You could like draw more cycles because it keeps going in here too, but we only need to draw one cycle. It says sketch one cycle. Okay. All right, so next problem, we have a cosine. Cosine's a little trickier. So unlike sine and tangent, cosine doesn't start at the origin with its graph, right? Cosine starts up or down if it's negative. So cosine doesn't start at the origin. That makes cosine a little bit trickier to do. Okay? So let's take a look at what we got here. Okay, so I've got a negative 3 out front and a 4/5. Okay, there's nothing adding here. So this one has a center at 0, 4. Okay, but remember that cosine starts up. So that center at 0, 4 is actually going to be where the midline of this is. Okay, like on the cosine graph, it starts up and goes like this. So that 0, 0 is actually along the midline of cosine, if that makes sense. So when you're working with a cosine graph, this starting point is like your midline. Okay, and then the amplitude 3, negative 3, so that means it's going to be going up 3 from the midline and down 3 from the midline, and it's going down first, so it's actually going to start down right here, starting at 0. Okay, so now how far is it going? Like, what is 1 period? So our cycles is 4/5, so 2 pi divided by the cycles will flip and multiply, right? So you can either say the 2 and the 4 will reduce, and then 5 times 1 over 1 times 2, so 5 pi halves. And what's nice is since we started at 0, we don't have to add. It's 0 plus 5 pi halves. So it is at 5 pi halves. So we started here and we'll be back there again at 5 pi halves. We'll be up to the top in the middle, and we cross our midline in between, and then draw in your cosine graph. All right, so yeah, this lesson's a little bit trickier. You might need to rewind, watch the video more than once. It's kind of hard. Be sure to ask questions. You know, text me questions through the Remind app or email, or hop onto my office hours on A days from 10 to 11 or 1 to 2. Use the Zoom link in the email I sent you. All right, so let's try a tangent graph. This is our last problem. So a tangent graph, tangent like sine, crosses through the axis. So you have nothing added on here, so our middle point will be 0, negative 2. So if we go to 0, negative 2, so there's our tangent midpoint. You can even make your midline right there if you want. This one's negative, so it's going to be going down, right? And then I'll put, you know, pretend like it's an amplitude like with sine and cosine, so I'll put values here so that people can see how much the stretch is. That's how I show the stretch. Okay, so remember tangent has a period of pi instead of 2 pi. So if we divide that, flip and multiply, right? So that makes 4 pi. We're starting at 0, so 0 plus 4 pi just puts us at 4 pi, right? So when we get to 4 pi, we'll be right here again along the midline. Put your asymptote, and now it's negative, so we're going to come down. All right, and there we go. Okay, so now try your homework. Use this in-class assignment to help you get on and ask questions. Make sure you take pictures of both the in-class assignment and the homework and send them to me. All right, thank you everyone.